Understanding how electromechanical products work will make you a better mechanical design engineer. Let's look at this fan. How exactly are we able to have two different speed settings and an off setting? We're going to study what happens right about here and how the speed changes occur. This video belongs to a playlist called the Mental Mechanism Library, in which we're going to study products all around us, figure out how they work internally, and save their mechanisms in our Mental Mechanism Library. This is going to make you a better mechanical design engineer. So as we can see here, we have the dial, and right now it's turned off, but as soon as you turn it on in the highest speed setting, so we have the dial. In the back we have the switch in black. So we're going to tear this apart and study the switch, what's happening inside. Now we're going to remove the switch. Here what we have is a crimp terminal or a crimp cap. And what we're going to do is we want to remove the off-the-shelf switch, but we can't because there's so many cables involved. So we're going to cut the cables right at that intersection inside the crimp terminal so that we can then disengage it and get it off, put it on the table by itself. And at the end, we want to be able to connect the cables again and see if the fan works. Sorry. Boom. Let's do that again on the other crimp terminal. Now we're going to remove the dial. It has a D-shaped slot, like the capital D. We're just going to pull it out. There it goes. We have our off-the-shelf switch, and we're going to pop these clips open so hopefully the wires fall off when we do that. Now we're going to remove the cap, and we're going to see that the wires, the brown wire, the red one, and the blue one, are pinned between the metal and the wall. So now we're going to go ahead and remove these wires by simply lifting them up. Blue wire goes right here. Red wire goes here. Brown here. Let's open the switch to see what's underneath. I think this is a very elegant mechanism. It's a rotating cam, flower shaped, as you can see, that will rotate independently from the housing around it. I want to highlight these V-shaped springs which serve as connectors for each cable. So as you saw before, the electricity from the wire will travel. Once it comes in contact with this V-shaped spring, that's what I call it, it'll travel through here. And if the slot is arranged in such way so that there's a piece of brass, which I'm going to show you underneath in a moment, if it's in contact, because as you can see there's in contact, the little brass, you see they're peaking. So the electricity travels, it'll come in contact with the brass, it'll come in contact with this side, and then flow into the fan. It'll come to a PCB, and the PCB will tell the motor what speed to run on, low, fast, or off. So that the PCB is like the brain. Depending on the level of current or voltage that the PCB receives, based on which wires are closing the circuit, it will dictate the speeds or if it's off. Now let's look at more of the mechanical side, how this all works. I'm going to take off the cam. This flower-shaped brass metal is what will dictate which, depending on which configuration it's in, it will dictate which of the V-shaped springs will have current passing through them. So let's do a quick example of that. There it goes. So let's do an example here. This one, I can see contact on this end. Let me see if the camera can capture that. the brass is touching indeed the V-shaped spring. It is also touching this one, but it is not touching this one. And when we turn the cam, what happens? This one is not touching the cam, this one is, and this one is. So the different configurations will dictate, you can't send a signal to the PCB, but the current will be different that's sent to the PCB, and that will dictate the speed and whether it's on or off. One of my favorite things about this mechanism is the V-shaped springs. Not only will they serve as the contacts for the wires, but it will also serve as detent mechanisms to hold the flower-shaped cam. Let's take a closer look at that. So they hold the flower-shaped cam in place, but they also serve as the contact points that allow the electricity to travel. And I thought that was pretty ingenious. And lastly, we have this cutout you can see right there. And if we look at the top of the lid, this cutout will prevent you from only rotating the knob 270 degrees approximately. That way you can't fully rotate the knob entirely 360 degrees when it's at the bottom. I want to use CAD SOLIDWORKS to really dig deep and be able to see what's going on internally in the small pieces. So we have the switch here. I took off the lid, and here we have the flower shaped cam, which I'm going to make transparent. The shape is slightly different from what I had in my hand, but for educational purposes it will do. So as you can see, there's the brass piece underneath that we can see, and I'm going to just go ahead and remove the rotating cam. And the configuration of the brass is such that only one of the V-shaped spring connectors is coming in contact with it. But now I'm going to change the configuration in case it didn't make sense when I explained it. And now two of the V-shaped spring connectors are coming in contact. So I hope now the point is clear as to how it worked underneath. As a bonus material, I'm going to show you a trick on how you can create configurations and move bodies in your multi-body part master model, which is the one I'm on, because we're here to learn from each other, and I am probably 3 or 4 years ahead of beginners, which makes me the perfect professor because I understand where you are, but I'm not too far ahead that I can't understand where you are, and when I explain things they're too advanced. I'm right in the middle, which is the sweet spot for a professor. So I'm going to show you how we went from here, this configuration, although it's not a configuration as you can see from the feature tree, how we went from here to here. What did I do exactly? As you can see, it's a move body. All right, let me show you. This comes in extremely handy when you're designing mechanisms. So we have the brass piece, and I want to do a function called move body. So I don't like searching for things in SOLIDWORKS. My thing is to type in the name. I remember the name of a feature and I just type it in. That's how I am. So I just type in move, okay, move bodies. I proceed to select the bodies already selected for me. It's called mirror 7. And then I just read from top to bottom. What do I want to do? I want to rotate it. But I found the shortcut to this. If you look closely as to what you want to do, we want to rotate it around, and it's this right here. So don't complicate yourself trying to figure out, this is what I'm telling myself, I'm not going to complicate myself trying to figure out which axis I'm supposed to do and which rotation. I'm just going to come to the screen and I'm going to rotate it. Simple as that. And then I click the green check mark, and there we have it. So if you found this tip useful, if you found this mechanism useful, please comment below or send me a message on LinkedIn. I'm Rafael Testai, and ask me what mechanism would you like for me to tear apart next and explain. Until next time.